Welcome back. So far in this course, you learned a lot on stream processing using Apache Spark. In this section, we will focus on taking it to the next level and learn to implement streaming joins. So let's start. Structured streaming supports two types of joins: streaming data frame to static data frame joins and streaming data frame to another streaming data frame joins. We will learn both of these joins with a suitable example. However, in this video, let's focus on the first one. Let me describe a simple requirement. Assume you are working for a bank. Your bank has a vast customer base, and some essential information about the customer is stored in the Cassandra database. Let's assume you have the following fields in your database: login ID, username, and last login timestamp. This is a kind of base data, right? On the other side, when a user logs into the net banking or to the mobile banking app, your system is generating an event and sending it to a Kafka topic. Each login event looks like the following. Now you are asked to read the login event and update the last login timestamp in the Cassandra database. And you should be doing it in real time using Spark structured streaming. Can we do this? Yes, we can. Let's do it. But how will you do it? Let me explain a straightforward approach. We will create two data frames. The first data frame is a streaming data frame for reading login events from the Kafka. The second data frame is a static data frame for reading user details from Cassandra table. We will join them on the login ID. Replace the older login time with the created time of the login event. And finally, we will sync it back to the Cassandra table. Make sense? You might find some other way to solve this problem. However, I am using this example to understand the join mechanics of a stream with a static data frame. Make sense? However, we cannot run this example unless we have a Cassandra setup. You can get Cassandra in many ways. Installing Cassandra and setting it up on your local machine is not in the scope of this course. However, the easiest method to get Cassandra is to use DataStax Desktop. You can get it from the following URL. DataStax Desktop uses Docker to run Cassandra in a Docker container. It allows you to install, run, and create Cassandra SQL from the DataStax Desktop application. If you do not have access to the Cassandra and want to try this example yourself, I recommend using the DataStax Desktop application. So, let's assume you have access to Cassandra database. I've got these SQL scripts to create a key space, table, and insert some sample rows in the Cassandra table. I'm using DataStax Desktop to demo this application. Here it is. Let me start the server. It takes a few minutes to create the Cassandra database in a Docker container. Once you have the Cassandra running, you can access it from localhost port 9042. However, you can access it directly from the desktop application. Create a key space. Then we use the spark_db key space. Now you can create a table. Let me do it. Now let me insert 3 records. You can paste the command string in this box using the Shift+Insert button. Good. I created 3 records. Let me check it once. Looks nice. That's all. We are done with the prerequisite to create and run the last login update example. Now let's create a Spark streaming project. Here it is. As usual, I'm creating a Spark session. Then I'm defining a schema for Kafka input. The next thing is to read the Kafka stream, extract the value field, and fix the created time data type. Up to here, we already learned everything. The login DF is my streaming data frame which holds the login events coming to the Kafka, right? What is next? The next thing is to read the Cassandra table to a Spark data frame, right? Let's do it. I'll start with the Spark session and use the read method to get a data frame reader. I'm not using read stream here because I want to read it as a standard static data frame, right? What is next? Format. Here is the format for reading Cassandra's table. We need to set at least 2 options. key space name and table name. That's all. Load it. However, Spark cannot connect to the database without the connection details, right? You can give connection details here in the options or set it in the Spark configs. I prefer doing it in the configs. Let me do it. We have two mandatory configs, hostname and the port. However, you should also set two more configs. Here are they. You can get more details about the Cassandra connector and these configs at the following URL. They have excellent documentation to explain everything. One more thing. Cassandra connector is not part of your Spark packages. So you must include the Spark Cassandra connector in your project dependency. You already learned to add dependencies to your project, right? Let me show you. Here it is. Great, that's all. We now have two data frames. The login DF is a streaming data frame which is reading a stream from Kafka. The user DF is a static data frame which is reading from a Cassandra table. Now we need to join them, right? The join implementation is the same as we do a standard data frame join. You need two things, join expression and the join type. The join expression is straightforward. logindf.loginid equal to userdf.loginid. And we are going to perform an inner join. What does it mean? The user must already exist in the Cassandra table. If a user does not exist, the join will not happen. And we will not update the last login timestamp. Make sense? Great. Let's do the join. Simple, isn't it? However, I want to drop the login df.loginid column because we now have two login ID columns after the join. Finally, we will create an output data frame. We will select the login ID, then username, and the last one is the created time, which I am renaming as last login. We are done except for one last thing. How do we sync it back to the same Cassandra table? We learned console, file, and Kafka syncs. Do we have a Cassandra sync also? Unfortunately, we do not have a Cassandra sync. But nothing to worry. Spark gives you an alternative to sync to any source, even if you do not have a sync connector. Let me show you. I'm going to create an output query. Same as earlier, I'll use the write stream. The next thing is to specify the format. However, I'll not set the format because I do not have a ready-to-use sync connector for Cassandra. So I'm going to use the for each batch method. The for each batch is a higher order function that allows you to supply a user-defined function. So let's assume I have a function for write to Cassandra which I can pass here. I'll create this write to Cassandra function in a minute. But before that, let me set other necessary options. We need the output mode, checkpoint location, trigger time, and finally we start it. That's all. We'll be waiting for the query termination. Done. So the overall structure is still the same. The micro batch will start, do the computation, create the final output data frame, and hand over it to the write to Cassandra function. Now you take the care of syncing it wherever you want to sync it, right? We want to sync it to Cassandra. So let me create the write to Cassandra function. This function must take two arguments. The first argument is the output data frame, right? The second argument is the microbatch ID. all we need to do is to start with the output data frame and write it to Cassandra. The format is the same as we used while reading a data frame. You also need the key space and table name. The connection details are already set in the Spark session, so we do not need them here. The output mode is append. We are dealing with the Cassandra database, and Cassandra implements the insert operation as an upsert. What does it mean? If a record already exists for the defined primary key, Cassandra will update the same record. A typical RDBMS would throw an exception, but Cassandra simply updates the same record. And that's what we wanted, right? Let me show you the output records as well. That's the power of for each batch. You can sync it to Cassandra. You can show it. If you want, you can sync it to another target. You have got full freedom of doing whatever you wanted to do with the output data frame. Spark simply considers that you are syncing it somewhere, and now it is your responsibility. Great, that's all done. Do you want to run it? Let me show you. We start the Cassandra cluster. Start the producer and send one input. Let me run the application. I got an output here. What does it mean? That simply means my Cassandra record should have been updated. Let me check. Great. So the last login time of this user is now updated. What if a new user joins your bank? His record should be created in this table as part of the initial sign-up workflow. So let me create a new record. Let me check it once. Great. So now we have a new user in the system. What if the new user is logging in and generating a new login event? Let me send one more event for the new user. We got it. However, this user was not there in the Cassandra table when we started the streaming application, right? But my changes to this table are picked up by the streaming job. What does it mean? Simple. Cassandra table is being reread in each micro batch. So, if new records are coming in your static data source, it should be picked up by the next micro batch. Make sense? That's all for this video. Let me quickly summarize. We learned to join a streaming data frame with a static data frame. Most of the time, these joins are used for stream enrichment. For example, you got a streaming record about a user, and you want to pull in some more information about the user from other static tables. So you can join your stream to a static table to get those details, right? However, we used a completely different scenario because I wanted to cover the custom sync in the same example. So we also learned to sync it to an arbitrary target. However, we could write to Cassandra so quickly because Spark already has a Cassandra connector. It doesn't have a streaming sync for Cassandra, but a standard data frame connector is already there, which we use to read and write from Cassandra. So, if you have a standard Spark connector, you can use the for each batch to create a streaming sync for yourself. Make sense? Great. That's all. See you again. Keep learning and keep growing.